welcome to this super splendid 7.2 lesson. And we're talking about similarity today. So many fun essays. All right, just a review over how we solve proportions, cross multiply. Oh yeah. All right, for the first one, I would accept the improper fraction 36/5, or I would accept the decimal 7.2 because that decimal ends. Either answer is fine with me. You don't have to have both, just one or the other. All right, number 2, still want to cross multiply. This one I have 2 different variables. No problem. Just going to have to distribute. X is 12. Yep, that's right. X is 12. And number 2. Okay, how are we doing those? Got that down? We have to know how to solve proportions in order to do the lesson today. So, all right, and then the last one here. I gave you the ratio of the side lengths of a triangle are 4 to 5 to 5. If the perimeter is 91 meters, find the length of each side. So an easy way to solve this that I kind of showed you was to just tag on an X onto each side length. Because if the triangle has a common ratio here of 4 to 5 to 5, and it's going to be times by some, we're going to talk about today. It's called scale factor, something that's multiplied to each side that keeps that ratio the same. And then I'm adding these all up because they gave me the perimeter, which is 91. That's how you find perimeter. Add up all the sides. All right. So solving this one, in this case, I probably want decimals if I'm talking about lengths of a side. I got X to be 6.5, but that wasn't what they asked me to find. They asked me to find the length of each side. So that first side, that's 4 times some scale factor, which ends up being 6.5. That's going to give me a length measure of 26 meters. And then the other two, that ratio of 5 times 6.5, that gave me 32 and a half for each side length. If I were to write those side lengths as a ratio and reduce it, divide everything by 6.5, I'd get back to that 4 to 5 to 5 ratio. Okay, so each side is some multiple of that ratio. What kind of triangle would this be? Isosceles. Nice. 2 congruent sides. So fun. Okay, so today we're talking about similar polygons. And similar polygons are 2 shapes that are the same shape, but not necessarily the same size of shape. Okay, so here I have like a couple quadrilaterals. All the angles are the same, but the side lengths are not the exact same measure. Okay, so I put same shape. That's what a similar polygon is, same shape, but not necessarily the same side. So. Okay. So we can classify 2 polygons as similar if and only if 2 things. All of the corresponding angles are congruent, and the corresponding side lengths are proportional, meaning they have some common ratio, scale factor, that I could write as proportion to any of the sides, or all of the sides, I should say, all the sides. All right, so looking here in this diagram, they're telling us that this quadrilateral ABCD is similar to WXYZ. Now, just like in triangle, actually, we did triangle congruency statements. Remember, I always made you like label the corresponding sides and corresponding angles. And I said like the order matters in which you list them. The order matters here as well. So if I want to write this in like math symbols, if I write this first quadrilateral, if I order it A, B, C, D, I have to keep the corresponding congruent angles in that same order when I'm listing my similar second polygon. So from A to B to C to D, I would go W, X, Y to Z. Now they're not congruent. They're not congruent. They have different side lengths. They're just similar. Because if I look at all of the side lengths in this quadrilateral, it looks like all the side lengths are exactly a third of what they are in this one on the left, right? A third of 15 is 5. A third of 18 is 6. So how we write this in math language, we want to say is similar to is this symbol right here. That means is similar to. So ABCD is similar to WXYZ, and the order matters. Because what you're telling me then is that if I list A first, angle A first, or vertex A first, that angle corresponds to angle W, and therefore they're congruent. Okay, so it has to go in that order. Similarly, AB would be the corresponding side to WX. Okay, so the order matters. All right, so I keep saying this word scale factor. Here's like the definition. It's a reduced ratio of lengths of corresponding sides of two similar polygons. So what they're showing you right here, this would be like the scale factor. So if I found the ratio of all the corresponding sides and I reduce them all, such as 15 to 5, that ratio, the corresponding sides, that's going to reduce to 3/1. There's your scale factor. Let's do another one. 21 to 7. That would also reduce to 3/1. That's your scale factor. Okay, that's pretty much like our big idea for today. So let's try a couple example problems here. In this first statement, they say, if triangle ABC is similar to, so they're not the exact same triangle, they just have the same angles and maybe, well, I should say maybe, they're telling us it's similar, and a ratio between the sides. So triangle ABC is similar to triangle RST. List all pairs of congruent angles and write a proportion that relates the corresponding sides. Okay, now you can't just go off of like looks of the picture because sometimes they flip the triangles and sometimes it can look kind of confusing. You have to go off the similarity statement. So angle A is listed first here. So since these are similar, it does mean that those corresponding angles are going to be congruent. So I'm going to kind of mark them as I go. So angle A is congruent to angle R. And then my next one here, B, would be congruent to S. And then C would be congruent to T. So again, don't rely solely on the pictures. This one's just a nice kind of easy first example. Make sure you're checking the similarity statement because that'll spell it out for you of which angles and which vertices correspond to which in each polygon. Okay, now it says write a proportion that relates the corresponding sides. I'm going to call this bigger one my blue triangle. I'm going to highlight it here. I'm going to call this one my blue. Oh, I'm going to call this one my green. So corresponding sides. Now that I marked all the angles, I'm just going to go from here to A to B, so the single arc to the double arc. A to B corresponds in my other triangle to RS. Agreed? Okay. I'm going to go down my triangle here. So BC. And notice how I'm keeping the blue ones on top. So if I'm going to write the ratio this way from blue to green, I have to be consistent because I'm going to set up a proportion here. So blue to green corresponds to ST. And then C to A corresponds in my green triangle to TR. All right, now these are not all congruent. Otherwise, they would have told me the triangles are congruent. Instead, they're proportional. So we're just going to set up one big proportion, like so, that ratio between the two side lengths, that ratio is going to be the same. They're going to be proportional. What I was saying is like these are not congruent. Like AB is not congruent to RS. Okay, the corresponding sides aren't congruent. Their ratios are the same. Okay, let's try one with actual numbers so you can kind of get an example here. So this one says, determine whether each pair of figures, in this case it's triangles, determine if they're similar. If so, write the similarity statement and identify what the scale factor is. If not, explain your reasoning. All right, now in order for them to be similar, they need to have all congruent angles. All the corresponding angles need to be congruent. And then the ratio between the corresponding sides has to be proportional to all the side lengths. So first of all, do I have all congruent angles between these two? Again, I'll color these. I'll call this one my blue, this one my green. Do I have all congruent angles?
Yes.
You betcha. This one's 59, and 35, and this one obviously also has to be the same. Okay. So now we just have to check if their side lengths, their corresponding sides, are proportional. So let's find the ratio from, I'll just kind of go up my triangle here, A to B. And if I start with my blue triangle, that's fine. I just have to be consistent. Ooh. So A to B would be from D to E. Let's figure out what that ratio is. We know AB is 6, DE is 4, and technically a scale factor is a reduced ratio, and we always like to reduce our ratios anyways, of 3/2. Okay, there's a ratio from the first corresponding side. Again, I'm just going to work my way down my triangle here. So now I see that BC corresponds to EF. Now, since, folks, in my first ratio, I wrote the blue triangle on top, I have to stay consistent with that. So this one's 9 to 6. What does that reduce to?
3/2.
Also 3/2. Okay, so far so good. We have a common ratio. Let's check our last side here. C to A corresponds to FD. So 10.5 to 7. Now this one might be a little trickier. You're like, whoa, decimals and fractions. Typically, you don't see decimals written in fractions very often. You can still use your calculator for this if you want, or you could just times everything by 10. Times top and bottom by 10, and you get 105 over 70, and then you could just reduce that. Whatever you need to do. But this does indeed, or again, use your calculator. Write it as an improper fraction. This does reduce to 3/2 as well. So, since the corresponding sides are proportional, all the ratios are the same. These would be similar triangles. So we could say, yes, we got to write a similarity statement. So, triangle, I'll call it ABC, is similar to, not congruent, is similar to triangle. Okay, I have to go in the corresponding order. So A corresponds to D, angle A. E corresponds to B. F corresponds to C. Oop. Write the similarity statement and identify the scale factor. So the scale factor is that common ratio is 3/2. Okay, now I do want to point out, technically there's 2 right answers for that scale factor. You could say 3/2. Anybody know what else would be technically correct? For their ratio? Don't think of this as like a different number. Think of like legit a different ratio. Yes?
3 to 2.
That is 3 to 2. 2/3 or 2 to 3. 2 to 3 would also work because it depends how I set up each ratio. If I would have started with the green triangle on top, I would have got a ratio of 2 to 3, right? So you just have to be consistent. So if you start with, green to blue, green, blue, green to blue, you get 2/3, 2/3, 2/3 for all those ratios. So that's fine. You could have either answer. Right? Put that in the homework that it could be this, 3/2 or 2/3 on the answer key. Okay, there's a great example of similar triangles. Let's look at a different type of example. Tan is designing a new menu for the restaurant where he works. Determine whether the following sizes of the new menu are similar to the original menu. If so, write the similarity statement and the scale factor. Explain your reasoning. All right, this is the original menu. It's the OG. Then I have two new ones. I'm just going to call you this menu 1. I'll color this one in blue. Menu 2 will be green. And then my original is going to be red. Okay. Now these are all rectangles, or we can see all of their angles are right angles, 90-degree angles. So all their angles, corresponding angles, are congruent. So that takes care of that. So in order for them to be similar, we just have to check if the corresponding sides have a common ratio. All right, so looking at the top of my menu, if I'm comparing from my original, I'm going to go from my original to the new every time. So AB, the top of my menu, corresponds to FG, and I'm given those measures. AB is 10 inches. FG is 12. That reduces to 5 to 6. Okay, there is the ratio between the top. Let's check out that side of our menu, the AD. So again, I'm going from the original to the new. I just have to be consistent. So AD is 12 to 14. Reduce that ratio, and I get 6 to 7. Uh-oh. Are those the same? No, that one's not similar. Not similar. Corresponding side ratios are different. Corresponding side ratios are not the same. Okay. Let's check out the green one. So again, I'm still going to go from original to new. So AB would correspond to the top of this, RS. AB is still 10. Now this other one is 8. Which we reduce to 5 to 4. Or 4 to 5, too. As long as you're consistent. So the side of the menu, AD, corresponds to 9.6, which is RU. Okay, same setup as the other time. You can either use your calculator for this, and if you don't know how to type this in your calculator, I can show you. Don't be afraid to ask. Or you can times everything by 10 and reduce that. But you do get 5 to 4 for that one as well. Okay, so because the corresponding sides are proportional, they have a common ratio. This one would be similar. So let's call this A, B, C, D is similar to, okay, I gotta go in that order. So I went top left, A to B, so I go R to S to T to U. Yes, those are similar. Scale factor, 5/4, or as I mentioned, technically you could say 4/5 as well. Okay, any questions? Just have a couple algebra ones, of course. And then one last thing I gotta talk about. Okay, let's throw in some algebra. I think you guys are ready for it. So this time they're telling us that these two polygons are similar. Now, I gave you a pretty nice, easy example where I didn't flip the polygon at all, but just be really careful. Well, I did on the next one, but just be careful and always go back to like the similarity statement and the order that they write these in. So AB would correspond to RS. So just like make sure it goes in the right order, because some of them can be kind of tricky. And then I see BC corresponds to ST. I'll do my other polygon. I'll do this one green. So I'm going to call this one my blue one this time, this pentagon. This one green. Okay, they're telling us that these are similar. So we know all of their corresponding angles are congruent, and we know that there's some scale factor, some common ratio between all of the side lengths, and they're all proportional to each other. That's what we know. So, looking here, I see that X is my side length CD, and I want to find that. And I know its corresponding side in the green polygon is TU is 3, but I'm like, okay, so you could start by writing this if you want to. You're like, I know the ratio from CD to TU is X to 3, but then you're like, how do I figure out what this is? Well, if you look back to that very first side that I highlighted, this AB, which corresponds to RS, I'm given 2 side lengths. So I can figure out what the scale factor is, right? If I know AB corresponds to RS, I can figure out what the scale factor is. Reduced is 3/2. So since this is similar, all the side lengths are going to have a scale factor of 3/2. So we can set up a proportion. I'll come over here. That this ratio is proportional to the scale factor. And then you could solve for X. You could call that 9/2, or you could call it 4.5. I'm okay with either. Technically, when I'm talking about lengths, I like decimals, 4.5. Okay, there's X. Now, they also asked us to find Y. So I'm scanning, and I'm like, oh, here's Y. Y this time is on my green polygon, which corresponds to ED on my blue. So when I'm setting up this ratio, I have to make sure I'm consistent. I already wrote my scale factor with the blue one on top. Okay, so when I set up this ratio, even though my variable is in the bottom, that's okay. I do have to set up the ratios consistently. So here's what I know. Here's what I know. I know that those corresponding sides are also proportional to that scale factor. So I'll set that up. I'll go over here. So just like we saw the last one, hey, we already figured out they're similar. We know the scale factor, so we can solve this one by cross multiplying. (13/3) is a repeating decimal, so that one we should keep as a fraction. If it's a decimal that isn't perfectly ending like 4.5, I guess is the best way to describe that. We want to leave our answer exact. Okay, good stuff. Any questions on that one? Okay, now the next one, you can't actually figure out the scale factor. Well, let's look at this one. And this one's a little confusing because I kind of flipped the triangles on you. So you're like, oh, what is 8 corresponding to that X plus 2, or does 8 correspond to that TS? And this is when you have to go back to the similarity statement here. So I'll call this one my blue one this time. LM in my blue one corresponds to TS in my green one. Okay, so although it kind of looks like 8 should be like the base, it's not. Okay, so if I know LM corresponds to TS, let's set up that ratio. LM is 8. TS is x minus 1. Now here's the issue. I'm not given a side length in each of my polygons to figure out what the scale factor is, right? I'm not given like, 10 to 20 or something like that. But I am given another ratio or another corresponding side. MN corresponds to SP. So we can set up another another ratio. MN corresponds to SP. And I know MN is 10 and SP is x plus 2. And I'm like, I still don't know that scale factor. But if these are similar, what do I know about these two ratios? They have to be the same. They're proportional. Yep, they have to be the same. Whatever the scale factor is, these have to be the same. So let's just set them equal to each other. Another proportion. And then we can cross multiply. So okay. X is 13. And that's all we had to find is x. Okay, I like that problem. One last thing we gotta talk about. One other kind of relationship between similar polygons. Here it is. And it makes sense because if their side lengths are proportional, then their perimeter, which is found by adding up all the side lengths, is also going to be proportional. Okay, so here's what this says. If two polygons are similar, then their perimeters are proportional to that scale factor between the corresponding sides. Okay, so here they're showing you this, how you calculate the perimeter, add up all the sides. That's also going to be proportional to all of those corresponding side ratios or the scale factor. All right, we're just going to try one perimeter one and then we'll call it a day. So here they're telling us that these are similar. Okay, good news. Find the scale factor between them and the perimeter of each polygon. Okay, one thing I want to point out, careful with your markings here. If they're marking, let's call this one my blue one again. If they're marking this in your blue, that means the other hash mark that is also 4, but that does not necessarily mean, even though they marked RV with 1 hash, that doesn't mean that this is also 4. Okay, we don't know that. They're just showing you that in each separate polygon. So in this polygon, actually, I'll call this my green one. If this is 7, this is also going to be 7. Okay, so just be careful with those markings. Please put it on my desk chair. Oh, it's going to get mixed in with geometry. Okay, so what else we know in our green one? If this is 10.5, this is also going to be 10.5. So the only side length we're really missing in my green one is that bottom length ST. So we could find that, and then we could easily calculate the perimeter of the green one. There's kind of a lot of ways you can tackle this problem, really. But I do know one ratio, and that would be, you could use either of these. I know, like, let's say A to E. So I can figure out what my scale factor is, because I'm given AE and its corresponding side RV. So I see that 4 to 7, which reduce, that's 4 sevenths. There's your scale factor. Okay, so let's find this side. I'm just going to call it X for now. On ST, because we know it's proportional, obviously, to this scale factor. So I'm looking up at my ratio, and I see I use my blue triangle on top, so I'm going to be consistent with that. BC, which corresponds to ST. BC is 6. ST, I'm calling X. Okay, so I know that that is proportional to all the other ratios of all the other corresponding sides and also the scale factor, 4 sevenths. Okay, let's solve this. Okay, that comes out to a nice clean 10.5. Yeah, 5 by 4. Yep, 10.5. So let's write that as a decimal because we're talking about a side length. Okay. Again, a lot of ways we could go about this. You're like, oh, well, if that's 10.5 and this one's 6, does that mean that these would also be 6? Yes, your thinking is right. But let's use this like rule that we just learned for perimeter. Now that I know all the side lengths of my green polygon, I can find the perimeter of my green one. So RSTUV, perimeter. I would just add these all up. We got 45.5 when I added those all together. Okay, now for sake of in a type of situation where maybe you're given what the perimeter is and you can't find all the other sides for some reason, I don't know if you're ever kind of doing like a word problem or something like this, we could easily find, without doing any more proportions to find these missing side lengths, we can easily calculate the blue perimeter by just setting up another proportion based on what we just talked about. Oh, not that one. This one, based on what we just talked about. That their perimeter is also going to be the same as that scale factor. So let's just set up one last proportion that the blue perimeter, which I don't know, I'm going to call that P. And again, I got to put blue on top since that's how I've been doing it with my scale factors and all that good stuff. And the perimeter to the green, that's also going to be proportional to the scale factor, the 4/7. And you could solve it this way. Now, if you're like, that's more confusing to me, I'd rather just go ahead and figure out what those sides are and add it all together. That's fine. But this would actually probably save you some steps. Let's see, 4 times, that's 182. Divide by 7, I got 26. Units. Okay, so we had to do that. And we had to identify our scale factor. I kind of already did that up there, but 4/7. All she wrote. Thanks for coming.